We are diving into Spanning Tree Protocol, or STP, a critical topic for your CCNA exam. The entire purpose of STP is to prevent Layer 2 loops. Imagine you have two switches with two links between them for redundancy. If a broadcast frame is sent, it will arrive at the second switch, which then forwards it out all ports, including back to the first switch across the other link. This creates an endless loop, causing a broadcast storm that can bring your entire network down. STP solves this by logically blocking redundant paths, ensuring there is only one active path between any 2 points in the network at a time. The absolute core of STP, and a major focus on the CCNA exam, is the election of a single root bridge for the entire switch network. Think of the root bridge as the captain of the team. It's the central reference point for the entire loop-free topology. This election is decided by the bridge ID, or BID. The BID is made up of two parts, a 2-byte priority value and the switch's 6-byte MAC address. The switch with the numerically lowest bridge ID wins the election. Here's a classic exam scenario. Switch A and Switch B both have the default priority of 32,768. Switch A has a MAC address starting with all zeros, and Switch B has a MAC address starting with all ones. In this case, Switch A becomes the root bridge because its MAC address is lower. Now, if you manually change the priority on Switch B to 4096, Switch B will instantly become the root bridge because its priority is now lower than Switch A's, and the priority value is always checked first. Remember this exam trap. Lowest priority wins, and if priorities are equal, the lowest MAC address wins. Once the root bridge is elected, every other switch, called a non-root bridge, must determine its single best path to get to the root. This path is determined by the lowest root path cost. The port on a non-root switch that provides this best path is called the root port. All other paths that could potentially cause a loop are put into a blocking state. Switches communicate all of this information using special messages called Bridge Protocol Data Units, or BPDUs, which are sent out by default every 2 seconds. A key concept you will be tested on is the different STP port states. A port transitions through several states before it can actively forward traffic. It starts in a blocking state, where it doesn't forward data but listens to BPDUs to understand the topology. From there, it moves to the listening state, where it starts to participate in the STP election process. Next is the learning state, where the port still doesn't forward user frames but begins to populate its MAC address table. Finally, it enters the forwarding state, where it is fully operational. There is also a disabled state for ports that are administratively shut down. A helpful mnemonic to remember the active states in order is Big Lions Learn Fast for blocking, listening, learning, and forwarding. The classic version of STP creates one single spanning tree for the entire network. However, Cisco developed a proprietary enhancement called Per-VLAN Spanning Tree Plus, or PVST Plus. PVST Plus runs a completely separate instance of spanning tree for each individual VLAN. This is a huge advantage and a common exam topic because it allows for load balancing. For example, you can configure one switch to be the root bridge for VLAN 10 and a different switch to be the root bridge for VLAN 20. This means a link that is blocking for VLAN 10 can be actively forwarding for VLAN 20, allowing you to use your redundant links more efficiently. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.